Hi, everyone. Thanks to ISKO UK for having me today. Welcome to my talk, Why Graphs? Transcending the Limits of Hierarchical Thinking. I have to begin by giving credit. In fact, I'm just going to go ahead and turn my camera off. There we go. Giving credit to this presentation's co-author, my former colleague, Aaron Leonard of Synaptica. He is in Africa and was unable to join us today, so I'm pressing on solo, but with the explicit declaration that we co-authored the original version of this talk, which was presented in March of this year at the Information Architecture Conference. Okay, I'm Bob Kasicek. I'm a taxonomist and information architect at Factor. Very briefly, Factor is an information architecture and human experience consultancy based in Seattle. We help organizations conquer complexity and unblock information barriers to provide information strategy and roadmaps for digital transformation. So in this talk, I'll be framing the ideas around topics in the book, 1,000 Plateaus. To quote from the book, any point of a rhizome can be connected to anything other and must be. This is very different from the tree or root, which plots a point or fixes an order. So I'll introduce some ideas from Deleuze and Guattari and their work 1,000 Plateaus and dive into trees, roots, rhizomes, and semantics. So as I said, this talk is framed around the ideas of Deleuze and Guattari in their work 1,000 Plateaus, which was written in 1980, and the English translation came out in 1987. 1,000 Plateaus was developed as an experimental work of philosophy covering a far wider range of topics than the previous book and serving as a positive exercise in what Deleuze and Guattari call rhizomatic thought, which is the basis for this talk about graphs. In the book, they propose many postmodern philosophical frameworks, and their exercise in rhizomatic thought covers psychoanalysis, science and the natural world, linguistics, literature, music and the arts, and a host of other topics. It's a very nomadic journey through many domains of thinking, tied together by common themes or lines. I'm going to focus on two main ideas and how they relate to the semantic and knowledge organization space and current ideas in work and technology. The first concept has to do with hierarchical trees versus, and, laterally organized rhizomes. Deleuze and Guattari structure their conceptual idea around the way plants grow, which is rhizomatically. Now, we know that a tree has roots, and these roots come from a common stem. A tree also has branches, and these branches also come from the same stem. Rhizomes, like the picture on the right, which are more like grasses or sedges, include plants like ginger and bamboo. And a rhizome also has roots, but they don't have a single root. They're actually underground stems, and they grow laterally. So from each node in a rhizome, another above ground structure can grow, and a rhizome can grow in any direction, including sideways and up. The second concept I want to talk about, is maps versus tracings. A tracing is a copy which stems from previous works or models, very much like the tree model of organization. Thus, a tracing is a copy that's linked to the idea of a hierarchy, whereas a map is an original exploration. It's open and connectable in all of its dimensions. Like a rhizome, it can grow in any direction, including laterally. Therefore, a map is graphical and linked to the representation and idea of a rhizome. So when we were reading Deleuze and Guattari's ideas, trees sound very much like hierarchical information organization structures, especially taxonomies. And it is these hierarchical categorization structures that they say explicitly are like trees. Opposed to the tree, or in addition to the tree, the rhizome sounds like the description of graphs and knowledge graphs. And this is how we made this connection between 1980s French philosophy and knowledge organization. And this got us thinking about how these philosophical and postmodern ideas are highly applicable to current semantic information and technology paradigms, which is what this talk is about. After all, as I like to say, disparate times call for disparate measures. Miller's law, from a highly cited 1956 paper by Harvard psychologist George A. Miller, states that the average person can only keep 7 ± 2 items in their working memory. Presented, say, with more than 7 or 10 things, humans tend to organize them into categories. When the list of categories becomes too cumbersome to remember or organize, we categorize the categories into hierarchies. We call this practice, very broadly speaking, taxonomy, the art and science of categorization. This is extraordinarily useful, and it can be highly problematic. Because hierarchies, that is taxonomies, are tree-like structures, we can see examples, of course, from Linnaean taxonomy of organisms or the Dewey Decimal System and many other examples. If you're trying to map out an organizational chart of people and roles and who reports to whom, hierarchies are great. Same thing goes for web navigation. Categorization projects involving tens or hundreds of thousands of documents, or even more, as we all know, also benefit from hierarchical categorization. It is a proved way to improve information retrieval via search and browse functions. And we know this. Strictly speaking, hierarchical taxonomies are limited to BT-NT relationships. This reciprocal relationship is the building block upon which taxonomies are based. This is very useful in a general way, organizing categories for easy comprehension and access. But there are issues, that is to say, there are limitations to this kind of thinking. The issue is that all hierarchies, or almost all hierarchies, are a flattening out of the relationships between concepts. Thesauri, that is taxonomies with additional attributes and relationships, skirt the edge of this problem by allowing related terms, which function as a sort of see also reference. In a strict taxonomy, not say a navigational taxonomy for a pet store website, but a strictly semantically organized standards compliant taxonomy, dogs and dog food are not a proper BT-NT relationship pair. As I like to say, dog food is not a dog. In a thesaurus, these concepts should be in different branches in the hierarchy. In my tiny example here, you can see dogs are under pets and dog food is under pet food. But we can point them at each other using RTs. People interested in dogs may also be interested in dog food. However, this does little or nothing to explicate the nature of the relationship between those two terms. It is not semantically expressive. We might use the same RT relationship to relate microscopes and microorganisms, but this is not the same relationship that dogs have to dog food. So the semantic richness between concepts is not adequately represented by hierarchical models. The semantic richness is flattened out, de-emphasized, or left out entirely. For a long time, limitations on information systems like hardware, software, memory capacity, processing speed, and throughput made taxonomies and thesauri the best available information structures for categorization activities. But we submit that this is no longer true. We should stop believing in trees, roots, and radicals, say Deleuze and Guattari. They've made us suffer too much. As a result, hierarchies and related terms are used as a compromise. Since expressive semantic relations, say telling us that dogs eat dog food or that microscopes are used to see microorganisms or bacteria, were not available, hierarchical structures are used to describe the semantic and conceptual links between concepts. This is sometimes done for practical reasons, business reasons, or system limitation reasons. However, if we are really interested in expressing and leveraging the semantic richness between the concepts, hierarchies are a compromise. They are not as semantically expressive as we require, and they are not as semantically expressive as the technologies allow what is possible these days. So if we want to model concepts connected to one another beyond hierarchies, in an open rhizomal type structure, we can build, instead of a hierarchy, but perhaps including several hierarchies and hierarchical relationships, a semantic network like the simple one shown here, with the credit for which I grabbed from the web and is listed at the bottom. The citation is at the bottom of the slide, which is modeled around a specific dog named Tom. But what's interesting is that the concept dog is actually semantically even much richer than can be modeled in a hierarchy alone. What's more, there are shades of meaning, allusion, symbolism, metaphor, and other semantically rich connections that we can make that aren't even shown in this little model. Whether we're trying to recommend or sell products or content or just model conceptual knowledge, there are ways, essentially ontologies and graphs, to create and deploy rich semantic networks. Hierarchies flatten out all of this nuance in favor of easily comprehensible and implementable tree-like structures, which are admittedly much easier to model and deploy. So don't get me wrong, hierarchies are extremely useful. Taxonomies aren't going away for some applications. But if we're interested in expressing and leveraging the semantic richness, they have limits that we need to understand. Most importantly, tree-like hierarchical structures imply rigid boundaries between topics that are actually conceptually linked. This limits the utility of applying such structures in information environments. To go back to Deleuze and Guattari for a second, this one sentence from A Thousand Plateaus may singularly sum up the point of the rhizome. A rhizome has no beginning or end. It is always in the middle, between things, interbeing, intermezzo. Whereas hierarchies are rigid and less flexible, rhizomes are always in the process of becoming. Taxonomies in the enterprise, for example, are never done, but their process of becoming is limited by their tree-like nature. They are rooted, and all following branching ideas emerge from the same stem. Rhizomes and their manifestation as knowledge graphs, at least that's our argument, are never done and potentially limitless in their growth. So here are some characteristics of rhizomes, both vegetative and semantic. Rhizomes are lateral and all about their relationship, since each underground stem can connect to or grow from any other stem. That is to say, their stems are not hierarchical or singular, they are multiple. The point of the rhizome is and. It grows laterally and without limits. The tree, say Deleuze and Guattari, imposes the verb to be, but the fabric of the rhizome is the conjunction and. Whereas hierarchies fix an order and emphasize that order, the to be of knowledge, the rhizome is decentralized. There is no single center stem of reference. The rhizome is democratized because there is no center, no tree root or trunk or stem. All points in the rhizome are essentially equal, with each part being as equally important as any other point. Deleuze and Guattari say any point of a rhizome can be connected to any other and must be. So not only can a rhizome grow between any points, it must. There are no points or positions in a rhizome, such as those found in a tree structure or root. There are only lines. That is the nature of the rhizome. It can grow in any direction, and it will. If you've ever tried to root out a rhizome, such as Bermuda grass, you know that it wants to grow in every and all directions. To quote Deleuze and Guattari again, a tree imposes the verb to be, but the fabric of the rhizome is the conjunction and. Now let's try and connect our second idea about maps and tracings before we dig into semantic graphs. A tracing is a copy. Tracings codify hierarchies and fix an order and define a de facto state. All of tree logic, say Deleuze and Guattari, is a logic of tracing and reproduction. So everything that is a tracing is a copy or reproduction of what came before. Tracings do not allow for new creation. So let's try and tie this to the real world of work in the semantic industry. In taxonomy work, consultants often recommend adopting and then adapting publicly existing vocabularies, controlled lists and taxonomies, thesauri, ontologies, or purchasing a taxonomy and moving on from there. Experts also often recommend working from existing structures within the organization. Again, these may be glossaries, lists, or pick lists that we find laying around an organization. All of these existing structures, which are often hierarchical, when reused and repurposed, can be thought of as a tracing. The same trees are traced and cloned. So let's say we have a client who creates an exact duplicate of their main taxonomy, and from this taxonomy, the copies are slightly modified to suit new clients and use cases, but the stem is always the same. This saves a lot of time, but it also codifies a structure. So as mentioned before, this can be very good. It allows us to standardize on common language, especially within known knowledge domains. But the downside is that we're always tracing the same tree and branching from the same roots and stem. The rhizome, say Deleuze and Guattari, is altogether different. It is a map and not a tracing. Make a map, not a tracing. Rhizomes form maps and foster connections between fields. These maps form connections at nodes and allow any information to connect to any other information. So a rhizome without a centralized point or stem always has multiple entryways. There's no beginning or end, only points of entry. And the rhizome connects any point to any other point. All the points are or can be connected to any other point in a way that's not possible in a hierarchy. So a subway map makes a good comparison to a rhizome and also to a graph, incidentally. Any point on the subway can feasibly connect to any other point in the subway. You can get on at any station and, making enough transfers or connections, get off at any other station. In a rhizome, the lateral roots or underground stems can be seen as the connection between subjects and objects, and each of these at nodes where the stems meet. Continuing the metaphor a little further, subways are underground stems connecting points and growing above the surface only at subway entrances and transportation structures. Every place you get on or off the subway is a new place. Similarly, every point in a graph is a new place or a new concept. The rhizome subway can be mapped. This map is not a tracing. It does not stem from a single point, nor is it a copy of another. It is a unique expression as a map. So perhaps it's obvious by now that our assertion here in this talk is that the map is a graph. A graph in mathematics and information science, is a set of subjects and objects connected by vertices. The subjects and objects are concepts, the vertices are relationships, and in graphs, they are first-class data citizens. RDF graphs are semantic and use a triple structure, as we probably all know, of subject, predicate, object. The predicate acts like a verb and is structured like SVO language structures. In the graph, like in the rhizome, subjects, relationships, and objects are all of primary importance. The relationships between things are as important as the concepts themselves. There are many ways to talk about these items, but they're all the same idea: subjects, nodes, and entities, objects, nodes, and entities, predicates, edges, vertices, and relationships. We call these many things, but this is the familiar RDF framework from which graphs are based. So here's a representation of a graph. In it, the circles are the concepts, the subjects are the objects, and the named lines, which can also have direction, are the relationships. A knowledge graph is a cartography or a map. It is a map, not a tracing. A knowledge graph is a specific type of graph which is mapping something new and making connections between concepts. These concepts may also be things, of course. Knowledge graphs are the rhizomes of the semantic space. Like a rhizome, knowledge graphs cross and connect related and different domains and fields. In a semantic graph, every concept can connect to any other concept by use of custom relationships. These concepts can be represented hierarchically in a taxonomy, and their rules defined by an ontology. So your map may include one or more trees. Concepts represent things. These things could be metadata, data, content, real-world objects, entities, or any other thing we care to model. In this knowledge graph, we connect subjects and objects with semantically meaningful relationships beyond broader and narrower terms, and we can define what these relationships are in accordance with what we are trying to map. So concepts can be represented hierarchically in a taxonomy. The rules governing the taxonomy are defined by an ontology, the structural underpinning of the knowledge graph. So we can think of the ontology as the legend of the knowledge graph map of one or more domains. The ontology defines the rules for what relationships are allowed between concepts, so we can create a semantically accurate knowledge graph. The legend to this map includes the definitions of which properties and relationships can be used between concepts and within and between schemes. Here we have concept properties for the concept name or preferred labels, synonyms or alternative labels, and a definition. We also have governance properties applied so users can annotate the concept. Relations are defined between concepts as in a single scheme as broader and narrower, and relationships are defined between concepts in multiple schemes using semantically expressive relationships. Each relationship is named, like a verb in a subject-verb-object structure. Character has film, people have actor, character has weapon, and vice versa, film has character, and so on. These relationships are meaningful and semantic. So when we make a knowledge graph, we're making a map, not a tracing. This means that information does not have to exist in buckets or boxes, because knowledge graphs allow us to connect information where it lives in any content management system or database in situ. So when we focus on relationship-based modeling, we can identify the subjects and objects These are the concepts, and we can then identify semantically useful relationships beyond the hierarchical and taxonomic, broader and narrower, and related. That is to say, we can extend and connect knowledge graphs within and across domains and content. This is the and instead of the to be. The supporting architecture for knowledge graphs include taxonomy and ontology management systems, graph databases, and integrated systems such as content management, digital asset management, search systems, and other databases. So at this point, perhaps you're saying to yourself, well, gosh, Bob, that's cool and all, but what does it have to do with me? To which I say, everything has to do with everything. That's the whole point. I do realize, however, that this is not very specific or helpful. So let's ask a different question. How can we plug the tracings back into the map, connecting our roots or trees back up with the rhizome? Consider a typical content and information environment. Perhaps I have some content, which is tagged with terms from a taxonomy or taxonomies. That content, once tagged, goes back into the CMS. It's divorced from the information system. You have tags applied to a document that go back into the content management system and are no longer connected to the taxonomy. Maybe people across the content access the content via search or navigation, like some part of the taxonomy is exported and then used in the UI, fed into the search engine. But the chunks of things that make up this ecosystem are effectively siloed. The system is not dynamic. If a tag changes, content must be retagged. If tags are added, content must be retagged, and so on. The tags don't connect to anything. They're words in an XML file. To be clear, this is better than not tagging content, and no one is saying that it's not, that tagging content isn't useful. It aids in retrieval and navigation and does all those good things that we know about and practice in our discipline. But what if we envision this structure instead as a rhizome? What if instead we put the tracing back on the map and connect the tree to the rhizome? We can model this same environment as a graph. Instead of siloed information with tags and extracted metadata, all these elements are included in the graph. The content, the authors, their affiliation, the tags represented here by UNESCO thesaurus in this environment, the journals, the countries the authors came from, and of course, other things could be added as well. This model connects information across silos and formats. The content still lives in the CMS or wherever the content lives, but it's represented in the graph. We've connected the roots and the trees back up with the rhizome. Ideally, we'd also use linked data to connect each point to external data sources. This will be clear if we look at an instance of this model. Quick note, I modeled this example using data from PLOS, the Public Library of Science, as they make all of their data open for analysis. So thanks, as always, to PLOS for that. This is a model of the information contained in a single journal article, displayed in the center in the blue node with the red circle. Now, every object in this ecosystem is indeed in the same ecosystem and connected to the graph. We have put the tracing, that is the tagged content and the extracted metadata, back on the map. Note that none of these things, the article, the record of the article, the affiliations, and so on, live natively in the graph. They are represented in the graph and connected back to a data source describing the author record or holding the XML of the journal article and so forth. The graph overlays and connects existing systems instead of ripping and replacing them. It is possible, as I mentioned, to expand this concept using linked data to put our tracing back on the big map of linked data by pointing each of these objects to a website, preferably a linked data source, at least for concepts, but it could include for an author their personal website or a faculty webpage or a bio or whatever. But in this ideal scenario, objects in your graph are connected to information sources on the web. Not to put too fine a point on it, but we call this a knowledge graph. Graphs are, both by nature and design, more rhizomal than hierarchies. It certainly contains numerous hierarchies, that's certain, but we have to put them back into the rhizome to make them make sense in the full map. There is no privileged top position, and everything can be connected to everything else, including the larger rhizome that is structured information on the web. So how can we say and? In a lot of ways, we already do this or aspire to doing this. In information architecture practice, this Miro board with client names removed and all that good stuff is pretty typical, and it looks very much like a rhizomal structure. But the execution of these kinds of plans, that is maps, often looks much like silos and hierarchies. We need to embrace systems and technologies that let us realize our rhizomal designs instead of flattening them out into trees. What would this look like? So I dug up a couple of examples that I think are reaching towards this idea. This example comes from JSTOR. In addition to traditional search and browse interfaces, JSTOR Labs several years ago came up with a new idea. What if the user could drop an article or a file of your own or even an image and explore related content? This allows the user to upload an article and drop into the middle of the rhizome without having to pick a privileged starting point to start an exploration, as it were, and explore around. This is a rhizomal situation. It highlights the implicit and explicit similarities and connections between artifacts, in this case, journal articles and books. So I dropped the Wikipedia article about 1,000 plateaus into this box here, and here's what I got. The text analyzer returns, in addition to a list of selected content, more on this in a second, a list of identified terms shown on the right that has extracted from the text that I uploaded, and the user can curate this to emphasize important terms by clicking on them to highlight them to search the related articles. On the left, the prioritized terms can be weighted and even augmented by the topics that the user supplies. I added something in your philosophy, I think. Manipulating any of these changes the resulting recommendations, the other related points in the rhizome that are being recommended, which themselves display, in addition to some basic information, their own associated topics. So here are the related items that the very top of it that got recommended to me. Clicking on one of these, these related items have topics of their own. And if you click on that, it'll add it to your related topics list that you're searching for. This strikes me as a very rhizomal way of thinking. One can explore topics, authors, and texts with no privileged entry point. Although not presented explicitly as a graph, the implicit connections between the objects here, very logically empowered by hyperlinks, which is important, makes exploration a very different experience than the traditional search box, although traditional search-like tools such as filters are available. Going back to PLOS for a second, trees, taxonomies are still very useful, and one or more trees may be embedded in or erupt from the rhizome. PLOS, again, offers a taxonomy browse for their flagship journal, PLOS One. As you can see in the upper left, there are about 265,000 articles in this data set. Users may browse the hierarchy with a convenient article count to find a topic of interest. Clicking on this presents the articles tagged with this topic. So if I click on genetic programming, it says there are 5 articles, and here they are. Selecting an article, in addition to actually finding the content that I clicked on, also surfaces the tags from the taxonomy that are associated with this article in green on the right-hand side here. These can be used to surf to other topic pages with corresponding articles. Again, although this is not presented in the UI as a graph, the idea is that there is more than one access point. You don't have to go back to the top and search for another topic. You're allowed to browse around the rhizome laterally by surfing from topic to topic or article to article. The tree is used to structure and connect and navigate the rhizomal body of content. So the rhizome is already there. We just need to make it explicit, that is, not siloed. The tree already strongly implies the presence of the rhizome. Expose the rhizome, connect all the points, put your tracing back on the map, connect the hierarchies to the data, connect the data to other data, connect all the things. Deleuze and Guattari say the tree is filiation, but the rhizome is alliance, uniquely alliance. So here are our calls to action and purpose. First, when making information architectures and knowledge graphs, think rhizomatically. Focus on the relationships as much as on the subjects and objects. Make a map, not a tracing. You aren't just diagramming what already exists, you are making a map of what should exist. What map do you need to build for your information? De-arborize, democratize, decentralize. Break free from restrictive hierarchies while using them to plug back into your map. Make information and knowledge accessible by creating knowledge graph maps rather than hierarchical, siloed information structures. Information can live where it lives, decentralized and accessible to the knowledge graph for users to enter at any point and connect at any point. And finally, connect the trees back up with a rhizome. Use taxonomies in your knowledge graphs to define definitive concepts with semantic relationships. Deleuze and Guattari finally say, where are you going? Where are you coming from? What are you heading for? These are totally useless questions. Thanks.